Welcome to the demonstration of the experiment 9, that is blinking LED. This experiment demonstrates about how to write the C code for blinking LED and how to implement this experiment using ARM7 evaluation code. Steps for doing this experiment are component study, writing algorithm, writing C code, debugging using the keys tool, and the board connection and realizing the output. We'll see each steps in detail. Hardware components and software tools required for this experiment are light emitting diode, the ARM7 evaluation board LPC2148, power supply, and computer interface. And apart from that, we need to have the jumper connection to establish the connection between the LED and LPC2148. So here we need not to use LED separately. The LED is a part of the evaluation board. So only we have to use a jumper to establish the connection between the LED and LPC2148 microcontroller. The circuit connection between the LPC2148 and LED is here. The LED 1 to LED 8 is connected to the pin 16 to pin 23 of port 0 of LPC2148 microcontroller. So here we can see the detailed connection between the pin 16 to pin 23 of LPC2148 microcontroller to the all 8 LEDs are in the board. So the tools used for this experiment are the key for debugging, and the flash magic is for downloading or burning the debugged code into the target device. Now we'll see the algorithm for blinking LEDs. The pin 16 to pin 23 of port 0 of LPC2148 microcontroller is connected to the 8 LEDs as shown here. These pins should be configured as GPIO. To do this, we have to use a register called pin select register, that is the bit 0 to bit 15 of pin select 1 register should be loaded with the value 0. The direction of these pins are configured as output because these pins are connected to the LED. The LEDs are output components. So to do that, we have to use a register called IO0DIR. So the bit 16 to bit 23 of this register is set 1, means if you set the bit 1 of this register, then the respective pin will be configured as output. So for example, here the pin 16 of the IO0DIR, the bit 16 of IO0DIR register is set 1, then the pin 16 of port 0 of the pin 16 of the port 0 is configured as the output pin. The next step is we have to make the all LEDs are on. To make the LEDs on, we have to make the LED operate in the forward bias. To make the LEDs to operate in the forward bias, the pin output, the value of the pins, output value of the pin should be 0. To make the output value of these pins to 0, we have to use a register called the IO0 CLR. The respective bit means bit 16 to bit 23 of IO0 CLR register is 1, means the respective pins of the port 0 means the pin 16 to pin 23 of the port 0 output value will be 0. So then the LED will become a forward bias, then LED will be on. Once the LED is on, you have to hold the LED on for certain time. To make the LED hold for certain time, we have to use the delay. We have to generate the delay. Then after the on for certain time, we have to make the LED off. To make the LED off means the LED should be reverse biased. To make the LEDs to reverse biased, the pins are connected to the LED should be high. The output value of the pins those are connected to the LED should be high. To make the logic 1 to the pins, we have to use the register called IO0 set, means the respective bit of IO0 register set register is 1, then the respective pin means the pin 16 will be 1. So those bits, the bits are 1, then respective pins will output will be 1. So then the LED are to maintain or to hold the LED off for certain time, we have to use we have to generate the delay for certain time. Then to make the LED on and off continuously, we have to make the steps from 4 to 7 to be executed repeatedly or infinitely. So this is about the algorithm. See how to write the code by referring the algorithm. Right? The basic step while writing the C program, it should be start with a header file lpc21xx.h. Then we have to declare the variable, what are the variables required for the program, and then specify the main function. The next step is we have to configure the pins those are connected to the LED as GPIO. Then we have to configure the direction of the pin as output. The respective bit 16 to bit 23 should be 1. Then only the pins those are pins 16 to pin 23 of port 0 configured as output pins. Then we have to make the LED or on, means we have to make the LED pins of port pin 16 to 23 value to 0. We have to load the value of the register FF, particularly bit of 16 to 23 as 1. Then to hold the value of IO0 CLR for certain time, means this value 1 or this register value 1 for certain time, means the LED on for certain time, we have to use a delay. To implement the delay, we have to use the for loop, means delay 0 to any number, it will be iteratively executed, so that generates the delay. Then we have to make the LED off, means the pins of each pin of 16 to pin 23 of port 0 should be 1. To make the 1 of the pin 16 to pin 23, the respective bit of IO0 set register should be 1, means bit 16 to bit 23 of IO0 set register should be 1. Then to hold the LED off for certain time, we have to generate the delay by using the for loop. And to make this LED on, hold for certain time, LED off, hold for certain time. To do this continuously, we can use the for loop or infinite for loop, means the LED will be blink continuously. So let us see the steps for debugging. Once we write the C code, we have to debug with a tool called Kill Microvision software. The steps involved for debugging. The first we have to create the project. The best practice is to create a new project. You have to create a separate folder for that. Give the name of project. Then you have to specify the target, which microcontroller or target board. Then here you have to say yes, because you have to write the code C program. If you are not writing the C program, you have to select no. Now create a new file and write the code, and then save that file, source file, and save it as .c file. Then that file has to be added into the project by using add the source file, the .c extension file which you created, that is added into the project. Now click on the build to perform the compilation, and check the error. You have to save the file and build or rebuild. Then start the debug. So even you can visualize the logic analyzer. You can use the port. See here, I am using the single pin number 16 of port 0. For that, you can specify that port 0.16, and here you have to select the bit instead of analog. So now we can run this full program. Here, instead of showing the output pin of all 8 pins, I selected only one pin, that is pin 16, to see the variation by here. For every execution, the output pin will be high for certain time and low for certain time, right? So logic analyzer can be used before implementing on the board to see the output of a specific pin like this. Now the program is debugged and verified logically as well as the syntax. Now we have to generate the hex file. For that, we have to go to the target and select the hex file. Then only you will get the hex file. Otherwise, for clicking the debug, there is no hex file will be created. So even you can check that hex file is created in the board or not. So after debugging, we have to do the connection. The mainly 3 connections we make sure that one is the connecting to the computer to whatever the compiled, cross compiled or the debugged code which is in the hex file to be downloaded into the chip. For that, we have to connect with the COM4 to the computer, and the power is required for the board. For that, we have the power connection here. The 5-volt power supply is required to connect this, and one more is the jumper connection to make sure that connection between the pins of LPC21 and LED. These are the 3 connections to be done before downloading the hex file into the chip. Then after doing this connection, now we have to download the hex file which is generated by using the keys. So click on the Flash Magic shortcut on the desktop. Then you will see this window. In that, you go to the option, advanced option, and select the target hardware configuration. Then select the device specification, LPC, the target device LPC21, and COM port. Make sure that which COM is connected to your computer. So specifically COM1, and you have to fix the baud rate is 19200, and this has to be non-ISP, and usually you have to consider 12 megahertz clock frequency, and you have to select arrays at flash plus code RD plot. Then you have to specify the location where you have to hex file has to download into the board, right? You have to browse the hex file which is created by Keel software, that is a debugged code. This is the location. Then you have to select the verify after the programming. Then click on the start. Not the error because we have not switched on the board. The connection we done, but we have not switched on the board. That's why it is throwing the error. Then do the connection and press the reset button. Then here the downloading. After downloading the hex file into the kit, so this display the finished window in the Flash Magic. Now you can see the